Hello everyone, welcome to ADS650 week 2. So before I start, I want to mention that some of you gave me very good feedback from first week's lecture. I understand it could be a little bit theoretical, especially considering some of you only just took one statistics class and have to join a more advanced class. So we will be introducing another textbook and very much applied, and it's very famous too, and it's online. So here's the website, and I'll base this week's lecture on the material from this book called Forecasting Principles and Practice, and often referred to as FTP2. Used by many schools, especially for business forecasting and for a very applied audience, which I feel we are. And when we need to cover more theory, we will probably go back to our original textbook. But other than that, I feel this textbook has the advantage of having a lot of very up-to-date functions, R functions, some very fancy functions, plot functions, which I feel will be very useful. And it doesn't go into much theory, but explains the applications very well. So we are going to also use this book heavily. So for this week, I'm going to go back to the origins of time series analysis a little bit, or the applications of it a little bit, which I didn't cover very well last week. So the textbook is called Forecasting Principles and Practice. So how is it related to time series analysis? So time series is usually used for forecasting in business applications. So a lot of courses are either called time series forecasting, which is forecasting, while the most of the material covered is really time series analysis. So that explains the title. And a lot of my slides will be based on this other textbook. So let's go back to a little bit more motivation for time series analysis. First, what can we forecast? So how can we, so what can we tell, about the future? There are many situations where we have to do forecasting based on time-related data. And the forecasting is very difficult, as we can see the International Monetary Fund try to predict the world GDP, from 2010 to 2020. So this is a prediction, their forecast, based on basically the true data in 2010, and keep on predicting for 2011, 12, and so on. So we can see the trend here was well predicted, but the rest of it is far from the actual, which is actually the black line, and so on. So this is a prediction of 2012, 2013. Well, this is the actual, the black line here. So it seems that there's a tendency of being too optimistic, and this is a percentage of change from year to year. So basically IMF is predicting a higher growth rate than the actual, basically in each year's forecast. So, and forecasting is difficult. Historically, people made predictions of many new inventions and new phenomenon that wouldn't take hold, but eventually all became very big. So that here's a collection of them, and of course, we're looking back at these predictions, and at that time it could have been, such predictions could have been legitimate in a way. And what can we forecast when you talk about forecast, the quintessential forecast most people want to do, or that interests most people would be stock market, and maybe exchange rate. And for those of us who work in industry, we probably need to always make forecasts for the claims, that we might encounter. So to set aside the reserve, and for property and casualty, the man-made disasters and natural disasters, and for life insurance, there are basically death and injuries, and for health insurance, we have to basically predict the amount of illnesses and treatments and so on. And another important area where forecasting is used, especially in our area, is there are some large energy companies, and they have to predict basically, the demand on energy is on various grids. I overheard about it, and so obviously people have to do a lot of simulations on time series, and it's very complicated. They do have a lot of data though. And almost all industry is somewhat related to weather, so weather forecast becomes incredibly important too, especially with I guess globalization. So what makes forecast easier? So a lot of things, might be just very hard to predict. So we can keep these in mind, for those things that we have a good understanding of, the factors that will influence the things we're forecasting, certainly that will help. And a lot of the data will be very helpful. And important and subtle condition is that the forecast we make shouldn't affect the things we're trying to forecast. So for example, stock price. If, say, a famous person like Warren Buffett, I guess, it predicts the stock price will go up for a certain company, and he makes it public, then that fact alone could affect the stock price. And we need there's to be relatively low natural or unexplainable random variation. I hope those will be, small, wouldn't be very affecting the forecast very much. And the most important, if we're trying to do time series analysis, is that we really need the future to be somewhat, or hopefully very much, dependent on the past. Therefore, we can make predictions. Time series data, we have seen some time series data from our textbook and from last week's lecture. So here's some additional time series data. So we're going to talk about the breakdown of such data in detail more today. So here's the crude oil price. So the yellow line, the orange line indicates the adjusted price, in terms of 2009 value. And we can see the long-term trend is almost impossible to predict, even though I'm sure people would be interested in the day-to-day change in oil price. But long-term, I suppose there's a demand change, based on a lot of, industry, requirements, and also people's consumption habits, and also world events. If there's a big world war, the demands and the price certainly will change. So in the long term, it looks like there's no obvious trends. And then there are things like yearly rainfall in California. So we can see a lot of ups and downs, and then the average stays kind of level over the last decade, almost century. So such going up and down in the cyclic kind of manner, we will see later, is called basically cyclic data. But we cannot quite see what the actual periods, in the cycles are. We can say, oh, roughly maybe 10 years or maybe 15 years or 20 years, but it's kind of hard to tell from this data. But we can see there's a cyclic pattern. It basically just goes up and down. And then we might get lucky with the time series trend that, time series data that just has a very, very clear trend, that makes prediction or with, all kinds of model easier to fit, as we will see later, as it here, Scottish fatal reported road accidents. Fortunately, it just keeps on going down. And the text will also talk about some case studies. So case one is a paperware company. Basically, they want to predict, forecast each of hundreds of items. I assume this is the consumption or the demand for each of the hundreds of items. So the series, there's no requirement from the customer, from the company. Basically they just want a large program written. They want to, basically good prediction method written to predict these demands. And they have a model, and basically they wanted the textbook's author to tell them what is wrong with their model, that it doesn't work. So there's some additional information. I'm sure those of us who work with data, especially in big companies where there's always a lot of data, but tend to be historical, may not be always correct or complete or quite the right data, will have very similar kind of issues as they have talked about here. So, old programming language, COBOL here, and programmer has little experience in numerical computing, which can be very, intensive in both in terms of programming and also in computation requirements on the system. And no statisticians were employed, and they just want the program to produce forecasts automatically. So as we have talked about the 3 or 4 main myths of data science, this is exactly one of them. People will think that they should just have one program and will just run on its own and forecast everything automatically. Well, it almost never happens. And the methods currently used, so the problem is quite simple. We just want to predict the future demands of these products. So some methods is a 12-month average from the past, or 6-month average from the past, or you can draw a straight line regression over last 12 months. This is basically using time as independent variable. It's different from autoregression. If we think about it, we've seen autoregression. What we were using as independent variable is always the previous value of the time series. But here is basically straight line regression through the actual time series curve. And average slope between last year and this year's values. So this is basically equivalent to differencing at lag 12 and taking the mean. So we'll see later on exactly what this means. And then same as age, except over 6 months. So unfortunately, these kind of naive predictions are used everywhere. Some of the companies I worked in too, not quite because there aren't advanced models, I think, in the cases I have encountered, but rather the data is so thin that whatever prediction we use wouldn't be very effective anyway, and people just want a simple explanation kind of to get over it and to put it in a report. But we will learn some more advanced methods here, and hopefully they will be useful to you in your future work too. So case study 2, PBS. So what does PBS mean? So it's actually a pharmaceutical benefits scheme in Australian government drugs subsidy scheme. Um, so so basically, I guess the Australian government needs to predict how many drugs, how much money they will have to pay out to, such benefits for drugs. So many things will complicate the model. First, many drugs bought from pharmacies are subsidized to allow more equitable access to modern drugs. So the prices may vary from year to year, and probably by a great amount. And the cost to the government is determined by number and types of drugs purchased. So for different amounts, the government buys, the price itself will change. So, and it's quite a large percentage of the GDP. And the total cost is budgeted based on forecast of drug usage. And as we can see, if the budget is not enough, then that could allow basically some limitation on the drugs, and that can actually drive up the actual price that the government will have to pay. So all of these complicates the prediction. And of course, there will be various government intervention going on. So the predictions, in 2001 is very much much lower than the actual budget, almost 20%. The under prediction is almost 20%. But the difficulty is a lot of products and seasonal demand, and subject to covert marketing, volatile products, and so on. And although monthly data is available, data are aggregated to annual values, and only the first 3 years are used in estimating the forecast. And I can imagine that actually the prices on the drugs will probably change year to year too, and the different new drugs will be coming out. All of that can complicate matters, and all forecasts being done with the forecast function in Excel. Actually, this is, I think, a very useful add-in to Excel. I think a lot of courses still use it, especially in business schools. Um, I think it's very useful, although limited. If you have this in your company and if you can get it and use it easily, not a bad option. But we will be using R for our course, which will give us a lot more powerful tools. So, and then the textbook talk about car fleet company. I feel of these three problems, this is probably easiest to predict, because the resale value of vehicles, and how should this affect leasing and sales policies. I feel because there's a large amount of data available, and car prices probably fairly stable throughout the years, although there will be newer types of cars coming out again. So that may complicate values a little bit. They, still compared to the previous two cases, this could be probably more predictable. And then there's the airline data. So economy class passengers between Melbourne and Sydney. So this is the data, and there's suddenly dropped to zero. It's probably just missing data, I believe, in these years from 1997, 1980. Well, could be this month. Could be that they just some missing data going on there. And hard to see much of a trend, but there should be some seasonality involved, although it's hard to see just by looking at this graph. So how to forecast passenger traffic on major routes? So I guess in Australia, you can do this, and it makes sense to for an airline company to do this, because I believe there was only back then there was only one airline in Australia. Maybe I'm wrong, but I think Qantas is basically monopolizing the Australian the airline industry. So additional information, they can provide large amount of data on previous routes, although I feel this may or may not be really helpful, because data, once the industry, the business environment changes a lot, the data may or may not be very useful. What if there's a new airline company competing, or international airlines competing? So that's all very hard to predict. And traffic is affected by school holidays, special events, blah, blah. And there's also a highly capable team of people who are able to do most of the computing. So for these large companies, which is a great, I guess, asset. So those are some cases that the author related to. I think for most of us, we can probably relate to one of these cases, one or more of these cases, and the business problems posed, and then the complexity of such problems. And we will not talk about these, basically such complexity later on. We'll be just focusing on the data. But just like what we have talked earlier in ADS650, so often it's such problems that makes the problem difficult, analyzing problem difficult, not the data or the model itself. So whatever we can do to improve what we can do for in the data preparation processing part, we should do that. So statistical forecasting perspective. So sample futures, of course, we can do different simulations, based on our model, and have these different projections of future data. That's not commonly done. Usually we'll give a confidence interval. For those of you who have taken, ADS650 or maybe some of the data mining courses, you will have seen the confidence interval, the prediction interval. But for those of you who haven't, it's just a range where we believe, so with 80% confidence in this case, that our prediction will fall into this darker purple area, and when here 95% confidence that our future will lie into this lighter purple area, actually this whole region here. And statistical forecasting, so what's the origin of it? What is the fundamental idea behind it? So first of all, we have a random variable y at t. So in our other textbook, we had x of t, but same kind of thing. And forecast distribution, let I be all the observations, then y of t given I means the random variable yt given what we know in I. And a point forecast is just the mean or median. It's usually mean of yt given I is usually written as the expected value of yt given I. And if we recall what we have seen earlier, more commonly it's really expected value of xt given what happened before at t-1, t-2 to whatever time we have. So that's the notation we have seen. And the forecast variance, this we'll have to go into a little bit later, but I think we have already seen a few cases of basically calculating the variance already. And the prediction interval or interval forecast is range of values yt with high probability. It's similar to the prediction interval or confidence interval we have seen in the previous page, but we're going to see all of these more later on. And with time series YT given T minus 1. So this is kind of a new notation which we should try to get used to. So in this textbook, YT given T minus 1 is really YT given all Y1 through YT minus 1. So that's just a simpler notation. And the H-step forecasting is that basically we only have values to time t, but we want to make the prediction H steps ahead of time. So it's given by this expression. So that is basically just some additional motivation for time series forecasting.